And as huge as that seems, that's actually going to rapidly increase. And by about 2020, you're going to have 50 billion devices. I mean, each of us is a walking radiation tower. You have your 2 phones and a tablet and a laptop, and so that's like 5 devices right there per person. So when we talk about security at scale, we talked about the heterogeneous environment. So you have all these different types of infrastructures that you have to manage at the same time, because some of the stuff's here, some is there. But then there's also the fact that attacks are nonstop. So it's not that the attackers are saying, okay, well, I'll attack you only once a quarter because you scan only once a quarter. No, the attacks are absolutely nonstop. So now you take the fact that your perimeter is totally distributed globally, and you have no handle or control over this perimeter because you don't even know what are the devices out there. And especially on the mobile side, when you have devices that are out there that your users are using on the road, these devices don't even come back to connect back to your infrastructure for days at a time. They are out there, they are connecting to the internet, things are being downloaded on them, but they are being attacked constantly. So now you have your different infrastructures and probably another 50,000 devices that are out there, which in itself, each of those devices is a perimeter by itself. So how do you protect that when you're sitting inside the organization? So that begs the question of how many attacks. So I tried to do a lot of research to figure out if there were any meaningful studies that were being done. And really the conclusion I came to was that honestly there's just too many to even, who cares, right? I mean, there's just way too many of these attacks going on at any given point. So the attacks are important because that tells you how badly you're constantly being attacked. But what's important is the breaches. So when a breach happens, you learn a lot from the breach. And if you look at some of the statistics that were being put out by the 2012 report from Verizon data breach report, you will see that 98% of successful breaches are coming from external threats. So while we obviously have to have a good handle on the inside, the external part is increasing because of the internet. It's becoming very easy for script kiddies to write things that just attack your infrastructure all the time, and they will get, the more they attack, the more chance that they will be successful. You also have to look at the good old hacking attempts. So when you look at people are trying to hack into things, there's different ways of hacking. There's the social engineering aspect, there's phishing, there's multiple things. But even right now, 88% of all the hacking attacks are using remote connections from the internet. So yes, you need to look at phishing and all of that, but that's the big one. That's where you're getting a lot of the attacks coming from. It's the good old remote access, and primarily because these things are coming at you because they're looking at you from outside. So they see the window that's open, but because you are inside in one room, you don't see that there's a window open in your house. So here's some more information on those statistics. There's a combination. So malware is obviously increasing and important, but a lot of the times the malware is actually being dropped into your environment just by using basic hacking techniques and by exploiting well-known vulnerabilities. So while targeted attacks and hacking attacks, all of them, and malware are very complex and very smart, they are using very well-known techniques to do these attacks. And as you will see that they have been increasing over the last 1 year. And in fact, while social tactics and physical attacks and privilege misuse, all of those are actually being used, you'll see that there's been actually a decline in that through that report. As I mentioned earlier, the one thing that is not being talked about quite a bit is that the web applications are really the underbelly of the internet. So these are the applications are being created and being deployed in your environment, and most people have absolutely no idea. I mean, it's bad enough that people don't have any idea. If I ask anybody today, how many devices exactly do you have in your environment, people don't know. But then web applications, that's even worse because, like I said earlier, You put a printer in there, you install some software, they all configure themselves using a web-based portal. They are sitting there with default credentials, or they are written by programmers who have no idea of security. They just put something together. But essentially now they are exposing you, and they are basically everywhere, absolutely everywhere, more than you can imagine. Why is web application security more challenging than network-based or host-based security? The reason is that web applications are custom built. So it's not like a Microsoft patch that is released by Microsoft and suddenly 1 billion devices are fixed as soon as you apply the patch. Almost every application that is written out there is unique. It's written by people who may be smart, may not be smart. Once the application is out there, you find an issue, you probably cannot even go back to find that person who coded it. And maybe in some cases, you actually don't want to find the person because he's the one who in the first place created the issue. But that's the challenge, is that to secure web applications, there's no magic pill here, you know. You have to understand every application individually. You have to put controls around that application that meet or suit what has been done on that application on the custom side. So the question is, do we feel like we're ready to protect ourselves against this onslaught with the tools that we have today? I think a lot of the activity that is being done for protection today is being driven by policy. And a lot of times the policy simply says, hey, you know, make sure you scan once a while, or make sure you review your logs every couple of months, and make sure you get some smart pen tester to go through your infrastructure you know, every 6 months. And you know, even mandates like PCI talk about the same thing, and they say, well, do you have one passing quarterly scan, and did you have a pen tester coming once every 3 months? Are the bad guys actually, you know, following the same schedule? I don't think so. They are out there, they're attacking you constantly. They are not waiting for your pen test to be done, or you know, the flaws are coming up all the time. And that's why there is a need for security to be continuous. Because if you look at going back to what I talked about, is there's an explosion of devices, there's an explosion of attacks. All of these things are changing dramatically, constantly. Just going in and saying, hey, I scanned, I looked at my house from the outside once every 3 months is not good enough, because yes, you might find that a particular wall is broken, but then there's windows that keep opening and closing all the time on your house, and you have no idea. But somebody who's sitting outside can absolutely see that, and they can use that to enter within the little window that they have. Most organizations have no clue that people are putting devices, and not maliciously. Your employees and IT people go and put a new server in the environment, and suddenly it's sitting there with a particular port open to the internet that nobody knows about, because they didn't even think that somehow there is a path to this particular machine from the internet. So, you know, you have to look at this from the outside. You have to look at it from the infrastructure that you have to build. It has to be looking at your house from the outside as the first step. Yes, you obviously need to make sure your house is strong from the inside, but looking from the outside is important, and it has to be continuous. And it sounds like, oh, this is preaching, and you know, this are some theory, but it's not. At the end of the day, when you look at what are the bad guys doing today, they are using continuous monitoring of your perimeter, and then as soon as they find something, they are attacking you. But you are not doing that. You know, you're still saying, hey, make sure, you know, this guy comes and scans once a quarter. So security, I think, absolutely needs to be continuous given the explosion of these devices. And the only way you can get continuous is through heavy automation. You cannot do this manually. You have to have a huge amount of automation to do that. And the security needs to be built into the infrastructure. So when you have all these little units of virtual data centers and physical data centers and cloud environments and mobile devices out there connecting to each other, connecting to the internet, each of these infrastructure needs to have the responsibility of securing itself first. So you know, I go back to the house thing, is you have to make sure that your house has alarm system, and you lock it, and you take all the precautions that you need to take to make sure that nobody's entering your house, and not just expect that the PCR van is going to come once every 2 days and going to make sure that your house is secure. No, this has to be something that every piece of infrastructure that you put out has to have security built into that infrastructure. And it needs to be always on, like I said earlier. You can't expect that you will look at it once every 1 month and it's going to be fine. It has to be constantly on. It has to be looking at everything that is going on in that infrastructure and using that information. So it's good enough, it's good to actually have it on and constantly looking at things, but then these things need to be analyzed all the time, because when an attack is happening, it doesn't take them 3 months to finish the attack. There's always the first sign, there's always a correlation, there's failed logins. You see a particular username is being used and it has failed logins on a Sunday morning when nobody's actually working. You cannot review these logs once every 3 months. That has to be done as things are coming in. You need to analyze that, and that has to be done through automation. It cannot be something that's manual, which is going to enable continuous monitoring. So while we've talked a lot about the various issues we have and the different types of attacks, really the only way you are going to even know about these are going on is you have to make some attempt to actually have some sort of a continuous monitoring approach for that. Kind of sounds impossible. I sound crazy, but I always sound crazy. But I think to get there, the tools that we have today need to evolve. So a lot of the tools that are being procured today are very enterprise sort of tools. They are point-to-point solutions. They are being installed in the environment because you have maybe 50,000 machines that you need to protect, and then they can go and reach each machine and they can look at it all the time. But that's a point-to-point solution. Now you have a solution that's looking at your antivirus that doesn't talk to a solution that's looking at your malware, which doesn't talk to a solution that's looking at vulnerabilities. So these are point-to-point solutions that are not talking to each other at all. And the advanced IT and security organizations are actually writing the sauce themselves to connect these and make sense out of it. But that's not very scalable at all. There is a need for a new architecture for security. It's not just procuring 10 solutions doesn't give you security. You need to have an architecture that will make sense out of the various tools that you're putting out there. And from that perspective, I think that a cloud-oriented architecture is really what is going to be suited for the future in the next 2 years, 4 years, 5 years, if not immediately right now. So what does a cloud-oriented architecture look like? So it's not that complex, but it's the same concept that I talked about earlier. Is you have to take the infrastructure that you have and ensure that that infrastructure is self-sufficient in its monitoring capabilities, and the security is built inside that infrastructure, and it is built in such a way that no matter where that device is and no matter where the infrastructure is installed and no matter who installed it, that infrastructure is constantly reporting everything up to a central place where you can now collect all of this information and not wait for your security solution to go and reach out to every individual device to try to see if the device is on and if you can get some information of what happened in the last 2 days. No. When something happens, it needs to be reported in a central place that's scalable, that can handle that amount of data, that can handle that amount of compute power from an analysis perspective. And as we all know, cloud-based solutions are really famous for doing that. The fact that they are elastic, that they can scale as per the needs. So when there's high activity, when there's an attack going on, you're getting a lot more information, and you need to have a strategy where you can have a platform where all of this information can come in and you can make sense of it. So I shortened the term to be COA as cloud-oriented architecture, but that's just an architecture, right? That's a concept that everything that you have needs to connect to some central place, bring all of that data. Now you have people who can look at all of the data, not in isolation, but together and make sense out of it. But that architecture has to be translated into a true platform, right? And that platform has to be globally distributed. So again, the whole point of having this cloud-based solution is that Those of you who are using Gmail, it's a lot more convenient to use because it's up there in the cloud. No matter what device you use, no matter which country you are in, it's right there. It's accessible to you. You land in another country, you open your browser, you open your app, and it's right there. You don't have to punch holes through your infrastructure to make it accessible to everyone. They just take care of it all for you. And it's globally distributed, no matter which country you connect from. I already talked about the fact that this should be embedded into the infrastructure. It cannot be slapped on later as some afterthought. Continuous discovery is probably even more important than continuous security, because in the ever-changing environment today, if you don't know that there's a device that exists and you're only protecting the devices that you know, you already failed, because now you have a device that you don't know about and you're not looking at the security, you're not looking at the compliance. This device is out there open for attack. So you have to have a platform that's constantly discovering and analyzing the discovery of new devices, because they're coming in all the time, and making sure that these devices are either approved and as per your image that you have built and what you expect from the device, or it's a rogue device and then it has to be looked at in a very different way. Analysis and correlation has to be done in real time. It cannot be something where you upload this data offline. I've seen organizations that do that. They just scan and scan and scan, and they collect logs, and then when the auditors are about to come, they will go and they will try to do something out of that, and they realize that, okay, there has been an attack going on. At the end of the day, why are these attacks discovered after like 2 or 3 or 4 months? Is because nobody's really monitoring the various telemetry that happens in the organization. One thing that the cloud-oriented platform must have, and it enables actually, is the fact that once you have all of this data in one place, today there's a lot of gap between IT department, operations team, security team, CSO, CIOs. So they buy the software and then somebody else implements it, and then they have to, the CSOs who sanction the budget have to sort of rely on somebody to give them a paper report that they can look at, and a lot of this is not making sense. But with the security platform, which is cloud-oriented, you now have all of the data that's coming into a single place, and now you can enable different views on the same data. So the IT team can have a view on what exactly do I need to patch. They don't care about the vulnerabilities. Security team cares only about the vulnerabilities. They don't care about the patches per se. They just want to see the number of vulnerabilities reduced. The CSOs and the CIOs, they just want to see that based on the data that they have, that the trends are going down, that the money that they paid for the solution is actually worth it, that they're seeing a reduction in the risk for these solutions. So this platform enables continuous security at scale at the end of the day, right? Because the whole idea that the backend infrastructure can scale on demand means that in theory there is no limit. You can add as many devices as you want. These devices connect to a central place. They update themselves. They report their security posture. And you can scale almost infinitely if you actually are successfully implement this sort of a platform in there. And as I mentioned earlier, the CIOs, CSOs, they want that full 360-degree global visibility at the end of the day. Scanning and discovering your assets every single day is actually very important, as I said, because the bad guys are not waiting to have an open window and then scan only on the weekend. It sounds very hard, but there are some progressive organizations today that are already implementing this. So we have organizations that are using the Qualys platform to scan 1 million IPs every 24 hours. So every 24 hours, they scan 1 million IPs, and they do the delta between those IPs, and they are focusing on what is changing. So they have that visibility. Instead of just looking at 500-page vulnerability reports after report on the different devices, they have really figured out a way to say, I'm going to scan all my devices every single day. They are actually successfully doing that today. As I mentioned, it's not just about the data that you collect from your own solution. you have to be able to pull data from different feeds that are out there and actually make sense out of that data and correlate with what you are seeing in the environment. So if there's attacks going on outside and they are exploiting a particular vulnerability, are you actually making use of that fact that in the cloud you have feeds that are coming from other organizations that can now correlate with the data that you're seeing within your organization? Enterprise solutions don't really do that today. When we talk about web application scanning, another reason why this sort of a cloud-oriented platform and scalability is important is security has to be built in the software development lifecycle. It cannot just be something that gets added on later, especially for web applications. So you need to make sure that the developers themselves are empowered to check the security posture of their applications. So if you have 50 developers, as soon as they make a change to the application, they should be able to test their own program to make sure that it hasn't opened vulnerabilities. As soon as they check their code into QA, in QA environment, there should be something that can scan these applications on a regular basis. When these things go to production, you need to scan the same application to production, and then you should be able to get a full view of everything that happened with that app, starting from the time that the developer coded it, what were the issues found, how were they fixed, how quickly were they fixed, and which were the issues that actually made their way into the production environment, and why were they not actually found. So the approach that everybody's taking for web application security today is here's my top 5 critical applications, and it takes me a week to scan my application, and then another week for somebody to analyze the data. And so I don't have the money or the resources to really scan all my applications that are out there. And that used to be the case with network scanning maybe 10 years ago, right? Where somebody would take a Nessus open source version on a laptop, and they could go in and they would scan everything, and then they would give you a report, and then they are gone. And because you couldn't have 500 people do this, you only really scanned those 500 important devices that you have. That's happening with web applications today. And there is a need for a platform where even application protection can scale to not just the top 5 applications, but to all 500 applications that you have. One of the things that comes out of having continuous security is continuous compliance. So there's compliance regulations that apply, and a lot of the security is actually driven by compliance needs, right? And compliance needs typically say that you need to, compliance needs will say you need to validate that you are compliant by looking at your infrastructure, by looking at your logs, by looking at your scans once a quarter. And what happens in practice is most organizations just take that as something that says when the auditors come at the end of the quarter, before that I will make sure that a couple of weeks before that I do my work and I have a valid scan to show them or a valid log result to show them. But in reality, what you need to validate is the fact that you are actually doing this throughout the year. It's not just 4 times a year. You need to be compliant throughout the year, not just when the auditors come. And again, if you don't have the visibility, you don't know what assets you have, you don't know what attacks are coming, you don't know what's going on with the devices, how are you going to be able to comply from that perspective? To make sense of, a little bit more sense of what I'm talking about when it comes to having a platform that's cloud-oriented, I talked a little bit already about, are you able to monitor your platform by the minute, right? Not by doing that every once in a blue moon, but really can you actually monitor that what's happening in your platform every minute? As I said, there are organizations today that are able to monitor their million devices on a 24-hour basis, and this is reality. This is actually happening today. There's actually organizations, global organizations that are looking at their perimeter infrastructure and scanning it every 4 hours, their entire class A, 16 million devices in 4 hours. It takes a lot of horsepower, but they are doing it because that is the only way that they can scale. The other thing is that Yeah, when you scan, you're going to get a whole bunch of vulnerabilities, right? Or you use different solutions. Are you making sure that you're scanning only the vulnerabilities that really matter or the important vulnerabilities? So yes, in an ideal world, you should fix everything. But in practice, you don't have the resources to do that. So how do you prioritize that? So this is where in a cloud-oriented architecture, when you have the full visibility, you should be able to pull information from outside sources, from exploitable databases. So you know that this particular vulnerability is actually exists, it's known, but it is not exploitable. So I don't want to probably put my resources in fixing that when there are 30 other vulnerabilities that are out there that are actually have exploits available in the wild that people can use to exploit me. I need to be able to look at those, and I need to be able to prioritize those. And that needs a lot of horsepower to be able to look at all the infrastructure that you have constantly and be able to tell you that these are the vulnerabilities that you should fix. There's a few malware solutions out there that are very popular these days with organizations, government organizations, and people buy very expensive solutions and they put those solutions in your environment. And the solutions actually tell you you have malware in your environment. Well, I'm pretty sure you already know that. I don't think anybody here feels that there is no malware in their environment. So they're telling you what you already know, which is that yes, there is malware. And then they're going to say, oh, that IP25 actually just downloaded an executable that has malware which uses this particular exploit to infest the machine. And they give you that alert, and now the real work begins now. Okay, if you don't have a way to correlate that piece of information with all the other information about that device, which comes from the fact that, well, okay, so that device just downloaded an executable .exe file. Hold on, but that device is actually a Mac, and that download just happened by mistake. I don't want to go spend my time looking at that. Maybe it is a Windows device. Do you know if the device is actually patched or not? So if the device is already patched for the particular exploit that the malware is using, you should be able to deprioritize that particular event to make sure that you don't go about chasing that particular event. Other thing is, if you do find malware in your environment, the next question is, how do I now go and look at all my million machines and see if any of the other machines are already infected with this particular malware or not? And if you don't have all of this information coming together in one place where you can analyze and correlate, I don't think that you're actually getting a lot of value out of these solutions, because all they're telling you is that, yes, this particular malware was downloaded, but then what? Again, I talked about the fact that web application security today is very manual. So the question is, when you find, if you're scanning a lot and you find vulnerabilities, you find cross-site scripting, SQL injection vulnerabilities, what are you doing with that after that, right? So it takes time to find the developer and to actually fix the application, and then to actually test the application and put that in production, making sure you don't break anything. That could be weeks, could be months. What's the immediate thing that you're doing? Most people are going to say, well, I'm using an application firewall. But taking that vulnerability from the scan and then going through it and creating a rule and deploying that rule on your solution, totally manual. That needs to be automated. Again, if the information, if your firewall is connecting to the same platform as your scanner is connecting, it's very easy to write something that says, when I see this, automatically create a rule and protect me instantly. Okay? So that's one thing that shouldn't be done manually. The other thing that happens again is, okay, so I found the SQL injection, I created a rule in my firewall to block it, but I want to go back and look at my logs for the last 3 months to see if I was actually if somebody actually tried to infect me by this particular issue. How do you know that? So today, somebody has to analyze that particular information from the scan, then they have to go to your log management solution, and then they have to manually do a lot of work to figure out if there are logs that are actually matching the pattern that are being seen during that attack. So again, if these things are brought in a single place, then all of this can be fully automated. One thing that everybody is a little bit scared about is when I say cloud, people think it's my data is going outside the environment. Everything is out there. Somebody is going to attack, and they're going to get all the data. And so cloud is a bad thing, and I don't want to talk about it. That's not true. I don't think that is true. I think there's a lot of organizations and a lot of techniques that are out there today that are available for people to go and make sure that your cloud providers, cloud solution providers are very secure. They're doing the job that they need to do. In fact, in a way, it's better because you can put clear mandates on the service, the cloud service, to ensure that they are giving you the right level of security.